Okay, let's move in this part to the tokens. We talked in details about the passwords and knowledge-based user authentication, and now we are going to talk about the tokens, token-based authentication, or something the individual has or poses. Okay, there are different types of tokens. If it can be categorized into two different categories. One is the hardware token, and the other one is software token. Software token is simply as an application or as your smartphone itself. If you, for example, you receive a one-time password from your bank or from Edugate to access your online banking, for example, in addition to entering your username, password, and then you will receive one-time password that you can use once and you have to enter it. This is considered as a software token, as the presumption there that you are possessing, you are having, carrying your pre-registered mobile number with you, that you will be able to receive that one-time password to prove that you are the one who is authorized to access it. This is about software token. The hardware token, it is a hardware from its title. It is a physical one, physical token. It can be a device or a card. These are different types of them. It can be even categorized into the normal or static token and smart token. If it is a static one, it has like a magnetic stripe, like a bar, similar to a barcode, like what we are having with our ordinary online, not online, with our ordinary card bank or banking cards, that the system or the device that you are going to enter it is going to read that magnetic stripe or code, barcode. The other type that is smarter or smart, it can have the memory on it that store, for example, your username and account number and other stuff, and it has also processing capabilities. So in addition to a memory to store some basic credentials, it has processing. It can process by itself some of the transactions. Some of them may come with a biometric reader, for example, that you need to put your fingerprint, for example, on it to prove that you are so and so, the authorized one. Or some of them may come with with a keypad that you need to enter an extra PIN, extra PIN, personal identification number, specifically for it. Some of them are contacts card that they have to be inserted into a machine or a card reader or touch it, and others are contactless, that they have radio antenna capability, that they can be from distance, can be read from distance. So these are what we have talked about. The drawbacks of tokens, as we mentioned in first part of this chapter, that sometimes it needs a special reader, so I need to use additional device to read it. Sometimes it can be lost, the token can be lost, and it can be shared as well with non-authorized persons. We said about the smart tokens that they have memory and processing capabilities. Some of them that they can be used to generate passwords. So they are called the challenge response. So you need, it is similar to in shape to a small calculator. You need to insert or enter pin number and then press processing unit, press processing button, and you will generate a one-time password that will be shown on a small screen on it, that you need to enter it on your account with your password or any other credentials. So as we said that the smart cards may have processor, memory, and input output ports. This is an example of the card reader that I think that all of us are familiar with it. That if we are using our bank cards for paying or purchasing things, some of the tokens that are currently in use are employed or deployed for electronic identity cards. There is a project that I have read about it, that even here in Saudi Arabia, that there is an initiative to transform our national ID to be an electronic identity card, or to have some of the smartness features that will aid us to use it as driving license and even a passport and for any other governmental transactions, but still it hasn't been completed or achieved yet. Some countries are using the passports, for example, to have some smartness features, some personal data that can be used to identify an identity or the holder's identity. They call it even sometimes electronic passport, or they call it e-passport or smart passport. So some countries nowadays are using this. Linked with it, usually, there are some unique, distinctive features that are linked with it and stored in it, in order to verify the holder with what is stored with it. For example, an electronic ID, regardless whether it is an ID card or passport, At the beginning, the passport authority will take the fingerprints and facial recognition and even the iris scan for the eye. They are going to be stored, encrypted, and stored on the government database as well as on the card, the e-card itself or the e-passport itself. Why is that? If the passport holder went to any airport, for example, or any port, and claiming that he is the one, there will be like a reader for his fingerprint or facial recognition or iris in order to verify his identity by comparing his current presented credentials, fingerprints, facial recognition, iris scan, with what is stored on it in order to say yes, that this is the one or not. We have even seen some countries like in Europe, as far as I remember, they have deployed such e-passport. So whenever we arrive to any European destination in the airport, there will be usually a dedicated track for them that they are not going to be admitted or checked by a personnel, but rather they are going to be checked by a device. It is like an ATM, for example, in terms of the physical shape, that they will swipe their passport and they will stand there to take their fingerprint or facial recognition, and then after the verification is received, and after comparing what he has presented to what is stored there on the passport itself, on the e-passport itself, and on the government database, so he will be granted access or rejected. These are how does it work. If you are interested to know how, you need to review this. But generally, a user request service via web browser, for example, the service will be requested from the host server or application server, redirect to EID message. The authentication request will go to EID server in the government, for example. They will ask the user for PIN, then it will be sent through or via authentication protocol exchange, and then the result of the authentication will be returned by accepting or rejecting. If it is accepted, so the authentication result forwarded to the host server and the service is granted. Otherwise, it will be rejected. So, what about the third type? Third and fourth, as we said, that static and dynamic are all together as biometrics in general. Biometric authentication, as we said, attempts to authenticate an individual based on unique physical or behavioral characteristics, based on pattern recognition. Technically, it is quite complex, as you can imagine, that compare the details of your fingerprint or the pigments and other features of your iris or the writing pattern or walking gait pattern or the voice pattern and others. It is quite complex and it is comparatively expensive somehow as it needs special processing features and special classifiers and special training periods in order to train the classifiers in order to reach a very high, unique or accurate results. Of course, this is compared to password and tokens. However, in some applications that they are highly critical and sensitive, we can accept that complexity and even a high cost. And on the other hand, with the current emerging technologies and emerging processing features, so I think that there are some of them that are becoming, let's say, less expensive than it used to be in the past. So this is a comparison between the cost and the accuracy of various biometric characteristics. So as you can see that the more accurate you are or the biometric method, the highest or the higher costs are involved. The more accurate the biometric characteristics, the higher cost is involved. See that voice has the least in terms of the cost, but its accuracy is questioning. Face, retina, iris, and so on. Biometrics, some of the biometric characteristics needs specific sensors, so they may need additional devices or hardware to read the samples of the biometrics, but others are not, especially with the new advancements of smart devices and smart phones in general. So they can, current smartphones can be utilized to read the biometric features like the voice, the speakers or microphone of the smartphone for taking the voice samples, the front camera to take the facial recognition, the screen itself or fingerprint sensor, the home button can take the fingerprint samples and so on. So generally there has to be an enrollment stage, enrollment phase. So these are the stages or the phases. Enrollment, or as we said, registration in other words, but the scientific word in relation to biometrics, it is called enrollment. So at the beginning, the user will need to enroll his biometrics on the database. So there will be like an identity check at the beginning, either the person has to come in person or any other features. it will be the biometrics in general, like fingerprint here, will be submitted. There will be feature extraction process here to take the features, the curves, for example, of the finger, the pattern, the others. Then it will be stored on the database. In terms for if it is a face, for example, the dimensions between the eyes, the dimensions of an eye, of each eye, of eyebrows, of cheeks, nose, mouth edges, and so on, will be extracted and then stored on the database. It is not necessary to enroll exactly the plain photo of your face or of the fingerprint, but rather and more securely the features that are extracted from that biometric sample. After that, if it is stored now in the database that this is the fingerprint and face of Abdulwahid, then when needed, when a user is going to request an access to a specific system or surface, he will submit his fingerprint. The features will be extracted for the newly submitted or presented biometric features. Then it will be compared with what is stored there on the database. As you can see here, that the comparison in terms of the verification will be 1 to 1. 1 to 1. When the user has entered his username, so the system will locate to the record of that username. If I entered Abdulwahid A, for example, so the system will point at the record of Abdulwahid, the user Abdulwahid here, and then we'll get the feature extracted at the enrollment phase, then compare it 1 to 1 to what is submitted. If it reached the threshold that we talked about it on the first part, the result of the feature matcher will be true. If it is less, it will be false. So 1 to 1. On the other hand, there is another way that that biometric can be used. It's just called identification. Identification, it is almost the same process, but without claiming an identity. So there is a claim of an identity here in the verification, but in identification there is no claim to the identity. Imagine that using the attendance machines or at your workplace. Just an employee when he comes to in the morning to the workplace, he will submit his fingerprint without saying that I am Abdulwahid, I am Ahmed, I am Adnan, I am Muhammad. No, just submitting his fingerprint. The finger features will be extracted and compared to all templates, all records in the biometric database. It will be compared with the first one, if it is equal or not, second one, not yes or no, third, fourth one, till it reach or it identify who is that, and till they find a match. So what is going to be checked there is whether this biometrics submitted or presented here is there in our database. If it is there, yes, okay. This guy is one of our staff, and then who is it? So does it exist? If no, so enough, we have done it. If yes, so yes, it exists. So who is it? Who is he? So this is Muhammad. So okay, Muhammad has present and has attended at this time. Okay, so this is the probability of the matching score. As you can see here, that there is a room for errors, for mistakes. Here, sometimes I said I am Abdul Wahid and I entered my fingerprint, which is the same as the fingerprint that I submitted when I enrolled in the system, but the system will not be able to verify me because he found that the matching percentage between my current fingerprint and to what I stored before is different, or it is below the threshold, even though that I am the authorized person, I am the verified user, but I will be rejected by the system. There is another probability that someone else is trying to impersonating me, and because there is a, a limited specific similarity between me and or between my biometric sample and what he has submitted, the system will allow him, even though that he is unauthorized, he is illegitimate user. The first one, that is that the genuine user, the authorized user will be rejected. It is called false non-match. False non-match, or in other words, false rejection rate. So it is false non-match or false rejection rate. I am genuine user, but I am rejected by the system by mistake. I am supposed to be accepted. Okay. On the other hand, there is false match rate or false acceptance rate. It is called false acceptance rate, FAR. That when an impersonator or imposter is trying to access the system, that he is not allowed to access it, and he is accepted to do so by mistake again. Okay, so between false rejection or non-match rate, FNMR, or FRR, false rejection rate, here FMR or FAR, false acceptance rate. Between them is the threshold. So if we move the threshold towards reducing it by reducing the matching score, the threshold, so the false rejection rate will be increased. If we move the decision threshold towards higher matching rate, so the false acceptance rate might be reduced as well. Okay, so by controlling the decision threshold, we will be able to control the the results or the errors that suits us, what is accepted or not, based on the risk assessment, as we said, based on the impact, potential impact, and in the assurance level needed. And this is between the false non-match and false match rate. And as you can see here, based on the biometric characteristics, you can see that iris here is or has the least false match rate. So it might be considered as the most accurate one here of these. These, all of these authentications, user authentication methods can be used to remotely authenticate the user. Remotely, we means that through the network, that the user is not required to present at the same location with the reader device, for example. Also, as we use in our daily use, that regarding the by accessing our email, for example, our online banking, and so on. So the authentication, the user authentication process is done through the network. So there are some threats because of that. It raises some security threats, such as an eavesdropper being able to capture a password while it's on its way, or an adversary replaying an authentication sequence that has been observed. Okay, the genuine user has access now his online banking and then signed out, but the attacker will capture the authentication sequence in the middle and replay it, resend it, the same one, resend it to the bank, and he might be able to access the account. To counter threats to remote user authentication, systems generally rely on some form of challenge response protocol for the communication. In this section, we present the basic elements of such protocols for each of the types of authenticators. These are some of the protocols that are used. The protocol for a password, protocol for a token, for the communication protocol for static biometrics, for dynamic biometrics. Each of them has its own security features that need a response from the host or from the user themselves to verify and to ensure that no one is eavesdropping it and no one is replaying it again. These are some potential attacks that authenticators generally are vulnerable to. For example, the client attack, if it is password, this is some of the potential attacks. Guessing, exhaustive search, how to deal with it, how to defend against it, having large entropy by increasing its complexity and length. So the time that is needed to break in is getting higher and higher. Limited attempts and so on. Go through them, think about them. If you can uh, cover this typical defenses and think about it, each one of them, how are you going to defend, and then uncover this and see whether you have got some of them or you have others. Here, one of the eavesdropping for the password is shoulder surfing. When somebody is behind you or near you and seeing the authorized person or while entering the password, for example. So here the defense is try to keep the password secret, try to not allow anyone behind you to see, try to cover the keypad while entering the password or PIN, use multi-factor authentication, etc. etc. These are some of the security issues. Some of them are mentioned there in the previous table. Denial of service. Okay, if an attempt to disable a user authentication service by flooding the service with numerous authentication attempts. Many authentication attempts is being sent to the server of the EduGate, while many students are waiting to register their courses. The server might be overwhelmed with this huge number of attempts, of authentication attempts, and then will not be able to deal with the genuine users and so on. Eavesdropping, host attacks, replay, so what we said, what we mentioned, client attack, adversary attempts to achieve user authentication without access to the remote host directly on the client's Trojan horse. All of these are in details. We are going to explain them in the following chapters. But here you need just to think generally about the vulnerability here, the potential risk here, and link them with the authentication method. Trojan horse, an application or physical device, masquerades, impersonate as an authentic application or device for the purpose of capturing a user passcode or biometrics. This is an example of the iris scan architecture for UAE system that they have employed it, and this is a case study. You can read about it by yourself. So in this chapter we talked about the authentication concepts, user authentication concepts in general, about how can we assess the risks for user authentication, and we talked about the three main types of user authentication: the knowledge-based, token-based, and biometric-based authentication. And we talked about the remote user authentication and some of its related protocols and security issues. Thank you very much.